Hello, welcome to our dietetic analysis with food vectors presentation for DiffyQ. I'm Zaid Fackenthal.
I am David Johnston.
I'm Will Enzor.
All right, for this project, we were tasked to construct, solve, and analyze linear systems from nutritional data to get a balanced diet. We used calculations through MATLAB in order to find determinants and row-reduced echelon form in order to calculate the theoretical best diet of 3 foods that we chose individually, and then 10 foods with those combined in addition to one more.
Cool. So, starting off with my 3 foods, I decided to look at the calories, sodium, and fibers for ramen noodles, eggs, and a Built Bar. Ooh. Looking at the RREF, you see that they all, exist in these categories. But unfortunately, ramen noodles will have 0 servings, with both egg and Built Bar having the same servings at 1.3, or at 1.13. So, yes. The determinant and trace are also shown on the right. The determinant coming in at negative 4.6 times 10 to the third, and the trace coming in at 52.5. The methods for how we solve both of those are shown on the further right.
I used the same process for my 3 foods of homemade granola, cheese stick, and barbecue chips. For my nutritional categories for this matrix, I chose calories, total fat, and saturated fat. Again, emphasize the first column would be calories, second total fat, and so forth, and then the rows are the 3 foods. And then when you look at the row reduced echelon form for my nutritional categories for these foods, I got roughly half a serving for homemade granola and cheese stick, and then almost 1 full serving of barbecue chips. And then the determinant and the trace are shown to the right as solved through MATLAB.
So, I did enchiladas, raspberries, and a Cliff Bar as my 3 foods. Here is my initial matrix that shows the calories, fiber, and carbohydrates for each of the foods, and also my B matrix. Then I have the reduced row echelon form of AB, and that shows I needed to have 0.3 servings of enchiladas, 0.04 servings of raspberries, which would be like just 1 raspberry, and that's kind of strange, and 1.2 Cliff Bars. Here's the determinant and the trace as calculated by MATLAB.
Cool. All right.
We chose Zaid's 3 foods, David's 3 foods, and my 3 foods to be part of our 10 foods. We also chose honey bunches of oats cereal with almonds. We looked at calories, total fat, saturated fat, cholesterol, sodium, carbohydrates, fiber, protein, calcium, and iron as our nutrients.
And again, each of those make up the columns of this 10 by 10 matrix.
Cool.
All right, so now when we calculated through MATLAB our initial serving amount, this is where we just guessed, let's just try 1 serving of each of our foods and see how far our error in overeating was for salt. So if you look on the left, we have a list of how much we overate in each of our nutritional categories. You could see we're over 100% on the bottom 3, which would be protein, calcium, and iron. And if you look at the bottom, our magnitude for how our eating error for these combination of serving sizes for these 10 foods was 340. Our goal is to get that under 100. So in order to decrease the amount of protein, calcium, and iron, we looked at our chosen 10 foods and decreased honey bunch oats, enchiladas, and homemade granola, as those had the highest numbers in the bottom, the last 3 nutritional components.
Cool. And as I said, we decreased those 3. We decreased them by about a half. Well, not even by a half. And that gave us much better numbers. Unfortunately, giving us 2 negatives, but bringing the bottom 3 down much lower. Still though, iron was over 100%, so that's the one we're going to again focus on lowering a bit. Um, on top of that, our magnitude of error was at 142, which is still well above 100. Although it did cut the previous one in about half, which is quite good. Yeah. Oh, that's right. The underlined sections that you can see, the Built Bar, Enchilada, Cliff Bar, and Honey Bunchers are the ones we're going to focus on lowering to better our numbers.
So, for our second serving amount trial, we wanted to increase the amounts of certain foods that had negative nutrients. So, the negative nutrients here were calories, cholesterol, and carbohydrates. And we wanted to increase foods that had each of those three nutrients in high amounts. The good thing here is that we had a total error of less than 100%.
Yep. So now in our final one, that was good. So now for our final estimated serving sizes, we did what Will said. And you can see we ended up with, for our estimated, 3/4 servings of granola, a half of a couple of our later foods, and then exactly 0.4 honey bunches of oats. And with this, we were able to keep our magnitude of planned overeating error under 100 with minimum negative values. Again, our negative ones here are in cholesterol of -6, and our lowest is of -16% for carbohydrate. And there was not much more we could do with this. This was the lowest we could reasonably get with our chosen foods. Not the most nutritional combination. However, with our iron, we still had the highest of 73% for that, but that was still much lower than our previous values. And in answer to the question, do we think our meal offers a qualitatively balanced diet? Well, if you were stranded on an island and these were your only 10 foods, then yes, this would be the proportions we would choose for you. However, you're not stranded, hopefully, and you have more foods available to you. So in that case, we would hope that you could meet your daily proportions of these nutritional values.
Cool. So our final calculated serving amount. This is where we took all of our foods and put them into row reduced echelon form, RREF, which, as you can see, by the primary diagonal having all ones, all of our solutions do in fact exist and are unique. But the numbers given directly from the RREF are not really feasible at all. They're not possible. You can't really have -4 servings of granola. So, because of that, we decided to strike out the negatives. They just no longer exist. They're no longer a problem for us anymore. So, when we now look at the data from there, you'll see things like, once we did that, we then looked at our overeating estimates, if you will, which, brain, okay. Cool. Yes. Okay. Looking at our overeating estimates, you'll see that we're still overeating way more than we were with our original. By a factor. Yeah. Okay. On average, our overeating was a factor of 161% based on the REF, while on average our estimates at the beginning were 20.1% above our daily intake. Yes, okay. The highest of these would be fiber coming in at 277%, and the lowest was cholesterol coming in at 11%. A couple of neat things about these numbers would include the 16 servings of barbecue chips, which is a lot, and unfortunately no servings of ramen.
I'd also like to point out on this slide is that you do see the nice diagonal of all ones. And while this also does show that our solution exists and is unique, is because no column doesn't have a pivot. But it also means that these foods are linearly independent, meaning none of them are dependent on each other and there are no free variables. Yeah.
Yep. Oh, one more thing. Our magnitude of overeating error was 558. It's a number.
Significantly more than our previous one, and let's hope our battery doesn't die. Moving on.
Yep, moving on. Ignoring that. Next. There we go, Will. This is you.
So, in conclusion, we thought about the question, what ways is this problem of planning meals different than other problems we have solved? And the answer is usually we deal with changing population over time and seeing the effects that certain actions will have or did have on them based on the data we have, like fishing in lakes or different breeds of wolves competing for resources in a certain area. Instead of looking for the effects of certain populations, we are instead trying to balance the different values to make sure they are all above the daily recommended values. This sometimes leads to unrealistic serving sizes using RREF, but there are still potential servings. There was a lot of room for variability in the user input due to the large data pool and the larger set of data points, 10 different foods instead of 2 or 3 predator-prey circumstances. Also, in this case, we were able to somewhat compensate for negative values for serving proportions by taking them entirely out and resolving them. But in other circumstances, you might not have been able to do this.
All right. Thanks for listening to our DiffyQ presentation. Eat healthy.